Alright, grade 9. So the last part of circles is we're going to be looking at some of the angles. I've drawn a picture here for you with a bunch of angles on them, and we're going to see that there's a relationship based on the points that make up each of our angles. Let's label the ones that we have on this picture to start. Alright, so I've labeled my angles with the central angle. That's the angle that is formed between 2 points and my origin. So I've chosen AB as my 2 points and my origin. And provided I use A and B as my 2 points again, but this time instead of using the origin, I use a third point, I'll create a new angle, and this one is called my inscribed angle. The central angle and the inscribed angle have a very unique relationship. And that relationship is that the central angle will always be double of what the inscribed angle is. Doesn't matter where those angles are on the picture, as long as you have a central angle and an inscribed angle to that central angle, the central angle will always be double. You can also take that definition backwards and say that your inscribed angle will always be half of what your central angle was. So here's an example of a simple angle problem then. I've got a central angle because I have my origin, which is connected to 2 points on the outside of the circle. And the question is, do I have an inscribed angle? The answer is yes, because I'm still using the same 2 points. They're just connecting to a different point on the outside of the circle. So it doesn't look as nice as the previous example, and that's the tricky part for this type of question. You have to recognize where your inscribed angles are, if you even have them. So this x value that I'm looking for is an inscribed angle, and using our definition, the inscribed angle must be half of our central angle, so x must be 25 degrees. Here's one more example that I could throw at you. I could ask you to solve for this angle, angle A, and only give you that angle B was 20 degrees. And on the surface, it looks like we don't have enough information. But this is where, again, we think outside of the box and remember what our rules are. We know that we have a central angle if there are 2 points on the outside of the circle that connect to the center of our circle. I should have labeled this to start, but this is our center of the circle where the diameter is. Put it over there. And our origin is connected to 2 points on the outside of the circle. Because it's a diameter, we know it's a straight line, and because it's a straight line, we know that this angle, this direction, must be 180 degrees, like so. How does that really help us? Well, now we actually have an inscribed angle. Angle C is joined by the same 2 points that made our central angle of 180 degrees. So angle C must be an inscribed angle. And if it's an inscribed angle, it must be half of our central angle, which happened to be 80 degrees, which means our inscribed angle is 90 degrees. And for a square, you can write 90 if you want. How does that help us? Well, we already know this is 20, and if we already know that this is 90, and we have a triangle, we need all 3 of our angles to add up to 180. So 90 plus 20 gives us 110. 110 plus what gives us 180? Well, x must therefore be equal to 70 degrees. Okay, so that's a slightly more challenging problem. I'm going to throw some really challenging ones on your practice just to see how you can do with them. Do your best. If you have any questions, as always, just let me know which question you're on, and we'll take things from there.